stop and see him in between classes today. Also, last call for state cross-country shirt.
I got him graphic.
Get that order in, so you have to...
Totally forgot. They didn't think about it. I gave him the homework. The graphics are near the end. They didn't think about it. They have graphics for piecewise functions. But they need graph paper. What?
Why are students coming?
They're going to do graph paper.
Oh,
So they can't graph those.
I was literally not in here.
Dude, it's not.
I was.
There's getting cussed. I'll break it.
When you get concussed, by the way.
We're doing flyback, and then Amanda's head hit my head, her nose.
Right here.
I was like, if you get...
I was worried that you had graph piecewise. I didn't know how to do it.
I think you are, boy. I'm drawing the graph.
Probably they're going to put it in.
No. I ain't gonna move. I ain't gonna move. I ain't gonna move. Yeah, that's right. You walk. Hannah! Jeez. Have you ever played the game called Best Fiend?
No, I didn't.
Ward! Ward. No need to hear. That bag is right there. Yo, dude, I worked on the video last night. Dude, it's going well, dude. I expect that tonight. If tonight, because I still gotta edit like.
Yeah, school ones I still.
Yeah, I can. Ooh, yeah.
We gotta make out homework.
What?
We have homework in this class.
Yeah, I know. I didn't get it though.
We have homework in this class? Yeah.
Yeah. Did you check out my new video?
18 problems.
Have you checked out my new video?
No,
Look at it.
I've been doing homework. Was your name was done too?
No, I wasn't here yesterday.
Yeah, a lot of that
I
class
think
too.
Katie was done either.
What?
Well, we have a Spanish quiz. That's what I heard about.
No.
Are you ready for the Spanish quiz?
That's so fun.
Yeah. I don't even know what it's about.
So what we learned,
What are we even learning about?
like when someone asks you a question, you can answer it back in Spanish.
¿Qué te gusta? ¿Qué te gusta, Carlos?
Oh, yeah.
I asked you, what do you like to do? What do you say? ¿Qué te gusta, Carlos?
Yeah, how much do you have
My
there?
mom? You like to do my mom? You like my mom? You go, I'm gonna text. You're very funny.
How much?
Cool, we do this.
Why do you have a piece of paper?
Cool.
on your-
Cool. Cool, we get this.
All right. Okay. All right. Hey, what we're going to talk about today, we're going to go over the test we just took the other day to make sure that you guys get to see what your scores were on that. Let me
Did you
hand
test
that out.
yesterday?
That was a test we took what? Friday.
Oh, well,
So I want to make sure that you guys get to see your scores. You have a week from today if you choose to retake it. A week from today. I have not entered the scores online yet. The reason being is that I don't want to just enter just a test in your grade without having like at least some of those homework assignments, like the practice guide and something else, because this will be in quarter 2. And God, if you like had a bad score right away, it looks like it's impossible to get out. So, but I'm gonna hand these out here in a second. Let's see.
Well, yeah, I don't like it because some teachers just put a 0 in for right now.
Yeah.
That says I'm failing, like.
Yeah, and then
So
parents
I'm like,
freak
what?
out when your kid isn't passing or there's like a bunch of blanks in there. I just avoid it until it's graded and everything's ready. Then I'll put it in when it's in.
Yeah, my grades are all good here yesterday. I got 2 F's already. Just by missing one day. And they all are in that.
I don't really. I have an A minus in Spanish.
Yeah, I have an A in Spanish. Wow, dude.
No, some court.
Yeah, hey, in first word. I was speaking of it for then having a.
I have some guys in first quarter too.
Mr. Ward, didn't we have homework yesterday?
Nope.
Could I have a sheet?
It's right there. You know, it's a piece of paper. It's a piece of paper in your book.
Oh, it's right there. I'll just try to figure it out. I told you that yesterday. Oh, I thought it was like a worksheet.
That's why you put the
You
cheese.
like we have homework in math. Like, okay, good.
And it's online too. So thanks for logging on the website.
Huh?
The website.
The website. What was it? Oh yeah, that was a.
Oh yeah,
Oh,
crazy.
I need to put that on my task bar.
What was that? Yeah, I spent a lot of money on that website. You have to look at it.
How much money?
I don't even want to tell you. It's sick or something.
Probably that's all the salary. Get out of here, dude.
You can move
I
that,
see what
bro.
you're doing. Okay. In this video,
All right. Let me hand out the test. All right. Hey, you do not get to put these away. You have to keep them out in front of you. So, we're going to talk about the scores right now.
Oh yeah. Cool, actually. Ooh, I got big one.
Okay. So, no perfects. So there's no perfects on this one. So that means that we definitely have room for improvement here. Let's go over the actual scores here. Okay.
I missed one of them.
Okay.
I missed one. I'm bad. No.
He just helped me. Who's 3? Who's 3?
I expect that. What time is it?
Oh, really?
Did you get? What did you get?
Okay. All right. Hey, let's talk about your scores here so you can see what you did wrong, what you needed to do, why you missed a point here, why you missed a point there, why you missed a bunch of points, that type of thing. All right. So I just want to go over these scores so you can kind of see them, right? All right. Okay, for the first one, problem number 1, factors of 28. 28 is 1 and 28, you have to have that one. 2 and 14, 4 and 7. No other numbers go into it. Okay, that's every combination of numbers you can possibly have. So that was 3 points, there's 3 individual rows here. 3 rows, 3 rows of factors. On 36, there's a bunch, right? 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay? So a lot of people forget those. Now, the trick was you did have a calculator. So, because I know on some of them you're using calculators. So you could have just divided by 1, divided by 2, divided by 3, divided by 4, and just wrote down the numbers off to the side and see if it worked. If it was a decimal, then you didn't use it. So it was 5 points, it was 5 individual rows there. What I saw for the most part, whoever missed that question, it was because he tried to do prime factors, the wrong method. And that's the most common mistake. You missed 2 points automatically, you didn't do the right method. Okay? because I want factors, not prime factors. And I have left a little hint there, so you know what to do. Okay, first 10 multiples. I don't think we missed these. I think there was only one quick miss because somebody added wrong right here. All numbers are good up to this point, and then they put a 170 here. So here's the trick. Start with 0, then you just add 36, add 36, add 36, add 36, add 36. So that's how you get the list. Add 13, add 13, add 13, add 13. Or just 36 times 0, 36 times 1, 36 times 2, 36 times 3, and just get going. So, but it was 5 points. There's literally like 10 numbers there, so it was every 2 numbers. Question?
At first, when I was doing this, I was typing it, then I'm like, oh wait, I'm doing it wrong. So I said I had to erase it all over.
My goodness.
I'm like, because I said I got to be like,
You
learn
got
how to
like
roll.
huge numbers.
So then I'm like, yeah, this can't be right.
Alright. Set of odd numbers. The odd numbers are 1 through 43, the odds. That's the set of odd numbers. So 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 30. And what I've noticed, somebody was doing those, but then somebody skipped a bunch. Like, when I said a bunch, like, out of 11 there, you know, or actually 22 numbers there, they skipped like 14 numbers. There's like the number 9 was missing, the number 15 was missing, the number 16, or 19 was missing, the number 25, 27, 29. Like they skipped a bunch. Don't just for random numbers, give me the odd numbers. I didn't ask for composite or prime, I just wanted odds. Thought that was easiest. Okay, set of numbers that are multiples of 10. Multiples are what you did on 3 and 4. 10 times 0, 0 is not on the list. So 10 times 1, that's on the list. 10 times 2 is on the list. 10 times 3 is on the list. 10 times 4 is on the list. Or 10, 20, 30, 40. These are the 4 numbers that are actually on that list that are multiples of 10. Okay, the factors of 100. There's a few, right? There's a few factors of 100. 1 times 100. You can't use the number 100, but you can use the number 1. It's on my list. 2 times 50. 50 is not on the list, but the number 2 is, so I'm allowed to use 2. 4 and 25. That's fine. Those are both on the list. 5 and 20. Those are both on the list. And then the number 10. The number 50 is not. The number 100 is not. Those are the only 2 numbers you cannot list right there. Okay. Any questions with number 7?
I have 1 and 5, but you kind of close them off.
Yeah, but did you have all the others? That's what I'm looking for. Sure.
5. Oh, I put 15.
Oh, there's your mind. Never mind. All right. Okay, moving on. Let's go to the next page. All right, so second page now. This is problem number 8. Okay, these are with 4 points. How it worked? It was every 2 words is a point. 1 point, 2 point, 3 point, 4. That's how it works. So 4 points per row. Okay, is this number divisible by 2? Yeah, it ends with a 4. Duh. Is it divisible by 3? No. When you add these up, you get the number 7. 7 is not divisible by 3, so that's a no. Is it divisible by 4? No. The last number is 14. 14 is not divisible by 4. 12 would be. 5, no. It doesn't even end with a 5 or a 0. 6, no, because 3 was no, so 6 is automatically no. Has to be both the yeses here. 9, no, because when you add these up, you get 7, not 9. 10, no, it doesn't end with a 0. And 11, no, because when you add these numbers up, it doesn't equal the middle number, the 1. So there's a bunch of no's. It was literally 1 yes and a bunch of no's. That was pretty interesting. Okay, for the next number, 65,320. 2 is an automatic yes, ends with a 0. 5 is an automatic yes. 10 is an automatic yes. Now the next numbers I don't know, like the number 3. If I add these up, this is 5 plus 5 is 10 plus 6 is 16. 3 does not go to 16. 3 goes from 15 to 18, but not 16, so that's a no. 4 is a yes because it ends with a 20. 5 is a yes. 6 is a no because that's a no. 9 is a no because it has to be 16, not 18 or 9. 10 is a yes, ends with a 0. And 11, I believe 11 is a no because when you add up these numbers, that's 9, that's 7, they're not the same numbers, so that's a no. You add up every other number. That's how it works. All right, let's go to the number 9. Okay, you had to create a number. You know what the easiest way to create a number? And I never told you this. Create a number that is divisible by 2, 3, 4, 5, 6, 10, and 11. You literally just multiply by each of these numbers. If you just multiply those numbers on a calculator, you get a number that works every time.
Why don't you tell us that?
Oh, because I didn't want to. So, now, what you could do is you could create numbers that are just divisible. Like, if I create a number that, is divisible by 6, so I use the number 6. This is how I created this number. 6, 2 and 3 is automatically 9. so I'm going to use the number 6. I'll take 6 times 5, so I need 5 to go into it. And that'll make a number that's also divisible by 10. So 6 times 5 is 30. And when I take it times 11, I get 330. Okay, that works. And if you want to make sure it's divisible by 3, I just multiply another 3 on there. So, or another 2. I just need to make sure that the number is divisible. So I just did mine as 660. But I could have made it a big number. That's the same what I do down here. If I want that second row numbers to work out, I need it to be divisible by 3, 5, 9, and 11. I just multiply those 4 numbers together. 3 times 5 times 9 times 11. And it works every single time. I just thought it was funny. No one figured it out. All right. So, moving on. Some people made up some numbers and I couldn't even read them, so I kind of took wrong. So if I can't read it, not a number. All right. Number 10. This is the prime factor. Some people were trying to do this method on problem number 1. This is the prime factorization, or stock, or however you want to call it. All right. So I divided by 2. That was 231. Now 2 doesn't go into that, but 3 does, because when you add these up, I can use number 6. So I divide this by 3. That's 77. 77 divided by 7 and 11. These are your prime numbers. So it's 2 times 3 times 7 times 11. And some people saying that there's like 2 7s. No, it's 7 times 11. That's 277. All right, the next one, number 11, the LCM. Now, I did mine by prime factors. Some people did like the list method, where they did like lists, all the numbers for 12, all the numbers for 15, like 12, 24, 36, 48, and then 15 is 15, 30, 45. And eventually you figure out 60 is the common number. If you do it by prime factors, 12 is 2 and 6, and then you break up 60, 2 and 3. So this is your prime factors. It's 2 times 2 times 3 is this. And then for 15 is 3 and 5. And what you do is you pick every number that you see. So I see 2s, 3s, and 5s. And then you pick the biggest power. So the biggest power is 2. So 2 2s, 1 3, and 1 5. So if you multiply those out, you get the number 60, which is the same as doing the list. Okay, for GCS, what you do is you do the prime factorization or factor tree, whatever you want to do. So 18 is 2 and 9, 3 and 3. And this is your prime factorization right there. 15 is 3 and 5. And what you do is you just pick what numbers they have in common. Look at a 3. And if you do by factor tree, 3 is the only number they had in common, other than the number 1. So you have to pick the biggest number they had in common. All right. You have a week from today, week from right now. So a week from today, Tuesday, so next Tuesday. If you want to retake this, all you do is you come in the morning, you come after school, we'll go through the prime team test and make sure that you know what to do and you can retake it. You will be getting a brand new test now. You'll have new numbers, but it'll be the same style. Okay? It's not the exact same test. You can't just memorize your answers. So you got to show me without a doubt you actually know what you're doing. And again, these will be entered online once I get the practice test and the other worksheet 2-7 graded, because I don't want to just use it right now. That wouldn't be fair to your grade, or your friends would be freaking out, your family, or getting C when you're not. The practice test and the actually affect the grade a lot. Okay. Today, all we're doing is we're doing some notes. You just need your notes out, please. Have your notes out. Okay, so, all right, so here's the idea. We're doing notes today. The reason being is that I'm not here on Thursday. You guys don't have classes tomorrow, but I'm not here Thursday. You'll have a sub here. And so I want to make sure that the sub has to be bare minimum for like notes for you. So that way you can just kind of work on an assignment. Now, we did have an assignment due today. So after I'm done with notes, page 60, 63, that is due. That's one where you have to take a picture, give me the fraction for the picture, or take a fraction, simplify it, and then draw the picture for it. Okay? So those are the ones we did yesterday. I'll give you some time at the very end of the class if you need to review on how to do that. But let's get rid of this thing. Okay. So section 3.2, which is proportions. All right. There's a couple different topics that we need to talk about with proportions. Number one, obviously, let's do the definition of what a proportion is. We're going to do the definition. We'll do kind of the key terms here. There's a couple vocab terms that we need to talk about, so that everyone kind of knows. And then what we're going to do is after that, we're going to show you kind of how we use this, like the main purpose of proportions. We're going to talk about the uses. This is pretty straightforward. So what we're going to be doing for the uses today anyway, we're going to be comparing fractions. That's going to be the one thing. Like, that's a big deal. Like, compare which fraction is bigger. Versus how to actually find missing values. Find missing values. So that's going to be kind of our key idea here for how this works. All right. Any questions with what we're going to do today? Pretty straightforward. I'll try to teach you some shortcuts here. I'll teach you the real way to do the shortcut. I think some people prefer shortcuts and stuff. But proportions is pretty straightforward. Let's do the definition here before lunch at least. Okay, so definition. Proportion. Alright, so definition is it's a comparison of two fractions using an equality symbol. So it's a comparison of two fractions, two ratios or fractions, there we go, say that. Maybe you want to put the word ratios. There's two ratios using an equality symbol. Some type of equality symbol. Alright, so let me give you an example like what a proportion looks like. So that way you can kind of like wrap your head around what this actually is. So here's a fraction. Half and 6 out of 12. These fractions are literally equal to each other. It's the same score. You got 1 out of 2 on a quiz versus 6 out of 12 on a quiz. You got exactly half of them right. That's the idea. Okay, that's why the fractions are equal to each other. But this is the idea. Now, it could be any type of equality symbol. It just said I didn't say an equal sign; it's an equality symbol. I can use the greater than or less than symbols, like this. Half is less than something that scored a 3 out of 4. Now, how this works? This is an inequality symbol, right? Inequality. This is some type of equality symbol. How the symbol works. When you read it left, right, it says less than. That's how you read this. Basically, how this works out, most people with this, I think of it, it looks like an alligator mouth to me, or a Pac-Man. So here's my little alligator. There's his snout, there's his mouth, there's his there's my alligator, and he wants to eat the bigger fraction. So he's chomping the bigger one. I know that's a terrible artistic drawing of an alligator, but there you go. Right? So that's the idea. So this fraction over here would be the bigger one. That's how it works. So those are symbols. We're just comparing them. That's all we're doing. Now, the problem is, what most people always struggle with is, how do you know which fraction is bigger? Like, other than, obvious one, right? How do you know which one is the larger value? It's based on the percent, like the decimal form of the fraction, but it's also based on, are your fractions even the same denominator? Do they have the same bottom number? Because right now, like, these are kind of easy to pick off of that, why certain ones are equal or why certain ones are different. But how do we compare is you make the denominators the same digit. So, like, instead of scoring different scores on quiz, you make all the quizzes the same score. So they're all 12-point quizzes. Or on this problem, they're all 4-point quizzes. And we can see how the scores change. That's what we're going to do. Okay? When we get back from lunch, we're going to talk about how to make that
Exactly. Where are they? What are those?
Actually, I should be
I don't
asking
know.
that.
Look at those. Look at those. Look at those. Look at yours.
How much I just spent $360 for this shoe. Yeah, if you're small too.
Yeah,
Good
but
Sean.
what things are
That's
yours?
really yours.
I'm cool. I'm 14.
Cool.
Your
Cool.
shoe. No, those are 14.
I mean, no, these are 13. My bad.
14?
Yeah.
You know, I'm lying. You have letters.
How can you fit into a size 9?
It works. They're comfortable.
Did you get those custom size?
All right. All right, so here we go. Let's go over kind of the last couple steps here that I want to talk about. We're talking about how to compare fractions today, right? So we were talking about, the equal sign versus the inequality symbol. But the problem is, like, how do you know that the fractions are equal? How do you know for a fact that one's greater than the other? And it's not just by ones and twos are smaller than 3 and 4s. That's not the idea, right? So that's what I want to show you. I want to kind of go over, how do we know in this certain case that certain numbers are bigger and smaller? So I want to start with this one right here. This 1/2 and this 1/2 and this 3/4. Okay? This idea, like really discussing why half is smaller than 3/4. Other than just common sense. Like, how do you know definitively that one is smaller than the other? So that's what I want to talk about. So here's how you do it. The trick is you find the common denominator. Well, on this, I'm not even going to think about what the common denominator is. What I'm going to just tell you to do is multiply the two bottom numbers together no matter what. No matter what they are. That way we're not thinking too hard about it. So what's 2 times 4? 8. So we're going to just multiply these numbers together. So we're going to put 8 on the bottom of both fractions. Okay? That way they have the same denominator. And no matter what the numbers are, you just multiply them. Now, on this fraction, how did I make 8? What did I multiply this to? 4. 4. I have to take the same number times the top. So if you multiply the bottom by 4, you have to take the top times 4. So this turns out to be 4 over 8. That's half, right? That's the idea. Over here, what did I multiply this 4 to make an 8? A 2, right? I multiplied that by 2. I'm going to multiply the top by 2. Now, do you see? Now that we have the same test scores, the test is out of 8 points, you see which one's bigger now. That's why the inequality symbol is facing the bigger fraction. That is the easiest way, the easiest way you can do it. It's not the quickest. It's the easiest way to do it. Question?
Could you just keep the 4 because 2 goes into 4?
Yes, you can do that. So if there's a smaller denominator they both go into, you could do it that way. So in that first fraction, so if you didn't hear full, on this half and 3/4 idea, just changing this one to be a 4 here. So I'm going to leave this 3/4 alone. But on this fraction, I'm going to make a 4 on the bottom because I can multiply the bottom by 2. And then take the top times 2. And now you can still see that this one is still bigger. That's the idea. It's the same thing. So without thinking about it, just the way that I always tell you, just multiply the bottom together. That's just how I would do it. But yeah, you are technically right. Okay, questions with that? No, that is by far the easiest way, not the fastest. It's the easiest. Question?
Isn't the fastest going by decimal?
If you had a calculator, yes. That is technically fast. You just take 1 divided by 2, 3 divided by 4, which decimal is bigger. But that's too much work, in fact, taking the calculator and typing it in. Here, if you want to see the fastest way to do it, not the easiest, but the fastest. Let's say we have 2/3, and we have 15 over 26. So, when you first look at this, which one do you think is bigger?
2/3.
Okay, all right, I'd probably agree with you on that. Now, to figure out, the fastest way to do this is what you do. You multiply from bottom across. So I'm going to take this 26 times the 2, that direction. So I'm taking 2 times 26. If I multiply that by 26, it's 26 times 2. If you don't know, that's a 2, that's a 1, that's a 52. Right? Or you can do by last number, whatever we're going to do. So that's a 52. Keep that number in your head. Over here, taking 3 times 15. So 3 times 15, so here's 15, I multiply by 3 diagonally, going up, right, up. This is a 15, carry 1, that's a 45. Which number is bigger? That fraction is bigger. Whatever side the bigger number is on, that's the bigger fraction. Now you're probably wondering, how did that work? You went diagonally up, like cross, and the bigger number is the one, whatever side you're on. So if the 52 is a bigger number, that's the bigger fraction. Here's the reason why. I'm literally doing the same math I did over there. I just didn't tell you that. Same math. Because really all I'm worried about is really the top number. That's really all I'm worried about, is what is the top number going to be. That tells me which one's bigger. The 6 is bigger than the 4, because the bottoms are the same. Well, that's what I'm doing here. I'm not worrying about what the bottom number is. I'm worrying about what the top number is. This is the fastest way to do it. It's the same concept. So let me show you why this is 52 and that's 45. Because originally, what I told you just a little bit ago, right? All right, so what I told you a little bit ago is that you get common denominators. So the common denominator here is you just multiply the two together. So I multiply this by 26 and multiply that by 3. So if I take this times 26, I take the top times 26. So the bottom actually turns out to be 8 carry 1, that's 78, and the top turned out to be a 52. And over here, if I multiply this by 3, I get the 78 again. And the top, when I take this times 3 on the top, I get 45. So do you see that the bottoms are the same, but the top is the big difference? Those are the same numbers I just showed you. You just multiply diagonally. And you gives you your answer which one's bigger. Now the problem is, it won't help you actually to see what the fraction is. It just tells you which one's bigger. Now, it seems like a lot of you have a really good understanding of fractions. Like knowing that 2 out of 3 points on a test is a better score than getting 15 out of 26. 15 out of 26 is about half. Half your points is a terrible score. But 2/3 is not bad. 66%. That's the idea. But this is like the concept. So the trick was you multiply diagonally. Okay. Questions, comments, concerns on anything I've done so far? Okay. Your first couple problems that you're going to eventually get later this week will be something like that. We're going to give you fractions. You have to tell me which one's bigger. So they'll expect you to put these symbols in the middle. The symbol faces the bigger one, or maybe they're equals, so put the equal sign. Okay? So that'll be the first couple. We'll practice these a little bit more later. Okay? Now let's do the second type of problem with proportions. Because this is just comparing. Now which one's bigger, which one's not. This is the second part. This is actually one of the main purposes of an actual proportion. Is this situation. This. Finding out what is the missing number that would make these fractions exactly the same. Questions? Or do you know the answer?
I'm thinking that I know it.
Okay.
But
What do you think it is?
Would be
What do you think it is? Because you had your hand up? Or do you just know the strategy how to solve it?
I know the strategy.
Oh, okay. All right.
I think.
Okay, so here's the thing. We're finding a missing number. I want to make both of these fractions equal. There's 2 strategies you can follow here. And this only works if it's easy. Okay? One strategy is called scalar multiplying. Okay? So it's called scalar multiplication. Okay, now how this process works if you want to know. It's what number are they multiplying so that you get your x number? Or what are they dividing by? Because it can be scalar division. So here's the idea. So I'm going to start on the side where there's more numbers. Okay? So do you agree there was more numbers on this side than the other side? Okay. What did they do to a 5 to make 30? What do they multiply or divide by? What do you take times 5 to make 30? 6. Do you agree that I multiplied by 6?
Yeah.
That's what you do to the top. You multiply by the same number. So what's 2 times 6? Say it again. 12. Okay. That's it. That's your answer. That's literally how you do it. The answer is 12 for the x. Question?
you could do it. You could take 2 times 30. And
That's the second strategy. You're thinking thinking of cross multiplying. Yeah, cross products. Yeah, and that's the second. This strategy is fast. Knowing, okay, did this number get bigger? Yes, so they multiply. If it gets smaller, then they divide it. So I multiply by 6, make that, multiply by 6. That's an easy process. You just take the top times whatever 6 is. All right, but the problem is with this strategy, you have to know what do they multiply by. Maybe it's a weird number. Maybe it's not a nice whole number. So that's why this strategy sometimes fails. The strategy you were talking about works every time, no matter what. And it is called a cross productor, cross multiply and divide. That's how they say it. So let me give you an example here. Let's go 24. No, let's go 28. Let's go 28. I don't want to make it too obvious. All right. So let's say this is 28, right? And I want to find the missing number that's up here. So whatever that number is, let's put a little N up there for a missing number. So what you do is you start with the number above or below the variable, the letter, sort of the blank space. So this is the blank space, right? So I'm going to start with the number above or below. So I'm starting with the 28. And how I remember to do this is you cross multiply. So I'm going to take the 28 times 3. So you do that with a calculator. And then you divide by the remaining number, and it gives you your answer. Okay? So whatever that answer is, you'll divide by 4. And that's the idea. And if you do this correctly, you'll figure out that the answer is 21, like if you do it correctly. All right? Now, let me explain how I think of that process. Because it's the same thing, cross multiply, divide, cross multiply, and divide. I call this the fish method of solving proportions. Why I call this a fish method? It looks like a goldfish. So the goldfish cracker, right? So you start with the number above or below your n, you cross multiply diagonally, and then you round off, you divide by the remaining number, and it looks like a goldfish. You can see it. It's a little fish. I don't know why. It always works. Doesn't matter where the numbers are. You will always get goldfish. The goldfish either faces that way or that way. It really doesn't matter. So, if I give you another one. Bulls, 100, and an X, that type of thing. Well, the idea is that, in fact, so X must go 25. Let's do it like that. It doesn't matter where you put your X at. You start with the number above or below it. You cross, multiply, and divide, and it always looks like a little goldfish. And I don't know why, it just always sticks with me. So you're taking the 20 times the 25, so that's diagonal, right? Cross, multiply, and then divide by 100. And if you do this, I think it's going to be fine. So that's the idea. So that's the strategy for solving. Now, the problem is, why? Why do we do proportions? What's the use of them? Why would we ever do this cross product? Why would you ever do that? It's used in a lot of different things. You don't even realize how many objects actually use this concept. So let's go to just kind of a list of where you can see this. This will be my last topic today. So this can be just kind of a crude example, and this is something that will apply to you guys eventually. Alright, so yes. Alright, so there's my car. Alright, there's my car. Okay, so here's my car, and I'm driving down the road, and let's say that on this car I have 18-inch rims. Okay, so I have 18-inch tires on it, and I'm going down the road 55 miles per hour. Okay. Now, I don't like my rims, so I decide I'm going to upgrade the rims. I'm going to get bigger rims on my car. I'm going to go 22s. So here's my car, same car again. And now I'm getting big 22s on. All right, so I upgraded to 22-inch rims. Here's the problem. If you don't go to a mechanic, or a place that actually replaces your tire, that will plug in a little sensor to your OBD port, which is a port on your car, which is where the computers run, and you don't get the computer calibrated in your car, you will technically be speeding as you drive down the road. Because a lot of people don't realize this. The car is programmed to to spin that tire so many times per hour, right? So when it says that you're going 55 miles per hour, your car is programmed to know how many times it needs to spin that tire completely around in an hour so that you go exactly 55 miles. That's what it's programmed to do. Okay? The problem is, if you don't get the computer fixed, it doesn't know any better. So it'll spin the big tire the same amount of times. So you'll be going way, way, way faster. So, in fact, if I show you the math, so here's my variable, right? So if I'm going down the road, in my car, and if I don't go to the car dealer or the mechanic shop, and I actually drive down the road, and the speedometer is telling me 55 miles per hour, this is how fast you're going. You start with the number of upper below x, you cross multiply, and you divide, and it will give you how fast you're going. So I need a calculator here. I cannot do that number. Okay, I can't do that. No, those are too weird for me. I can't do it. All right, so 55 miles per hour times the 22 divided by the 18. I'm going 67 miles an hour.
Okay, you think you're going 55?
But my speedometer says I'm going 55. And you probably noticed that. You've noticed that difference. That's way faster. You've noticed things are going by a little too quickly. Like, especially when you've been driving a long time. I can go from like Garner to Ventura, not even use a cruise control, and I know exactly how fast I'm going. It's just like this weird thing. Your brain just gets programmed. I can space off the whole drive all the way to Mason, look down, and I'm going exactly 55. I can just do it every single time, like on a dime. I don't even have to look at the speedometer. I just know how fast the poles are passing, how fast traffic's going. You just get a feel for it, right? You would notice that. Things would be whipping by too quickly, and you'd start slowing down. Okay? That's the danger of replacing your tire. Okay, this is the idea that when your car tires deflate, they lose air. You're going slower. Because your tire is now a different size. It's literally shrunk. So you are going slower because it's a smaller tire than when it was full air pressure. So your speedometer is also off. So that's something you need to realize, especially during the winter. The tires shrink. They lose air pressure. That type of thing. Okay? So that's why they tell you to go to the mechanics, always get the OBD port plugged in, and make sure that you calibrate your car so you're not speeding. Okay? Especially if you go from like, because that's big. I mean, that's going 18-inch to a 22. Those are big tires anyway. But like if you went from like a little 13-inch tire to like bigger tires, like 20-inch tires or 18s, that's a bigger jump. So you are going way, way, way faster. Okay? Especially on trucks. Truck is the number one thing. Guys, they'll have a truck. Some trucks have, little 18-inch tires on them, and some of those guys go really big. They get 30-inch mud tires. You could be speeding way faster than you think you are. And that's one of the first things that when you get pulled over and you're speeding, and the officer knows you have new tires, they can just see by the look of the tire, it's a brand new tire, brand new tire. The first question they're going to ask you is, did you get new tires recently? Because what he's going to do in front of you, he's literally going to check that math on a calculator in his pocket or on his cell phone. He can do that math. That's an easy concept to do for him. They're trained to do that. They'll ask you a simple question. How big were your old tires? And he'll look at the tire what you have now, and he just does this. Because he's automatically going to assume you were traveling the speed limit. He'll just type in the speed limit. Or he'll ask you, what did you have on there before? And he'll put the speed that he clocked you at. So he'll put what he clocked you at, what the speed should have been on the road, what you had previously, and he can figure out the math. Or he'll ask you a question like, what was your tire you had before? And he'll try to see if he can catch you in a lie. And that's the type of thing. You can get out of a speeding ticket if you know how to lie on that type of situation. But it's got to be obvious. You got to have a brand new tire, brand new tread, and it's pretty foolproof. That's a concept that a lot of people never think about. Guys replace tires on their trucks all the time without doing the correct steps. This is also used in baking. Baking is the same concept. Baking, you would, let's say you use like 2 cups of flour for every 3 sticks of butter, whatever it is, on that recipe. So you're going to upgrade the recipe. You're going to use 6 cups of flour. So how many sticks of butter will you need? That type of thing. It's proportions. The cooks do it all the time here at school. Like when they're making you your lunch, they're scaling it up. The recipe was for a normal cookbook. All they did was scale it up so it feeds more kids. That's all they do. If it's not one of those government issue things where they pop it out of the box and give it to you. So that's the idea. That's how you do it for a big batch of cookies when you're cooking for like a class or something like that. You scale it up, you know, how many feeds for 20, maybe you only need to feed 10. It's varying in half, that different. On Thursday, I know I'm not here, right? I'm gone. So your sub will be here, the sub will go through a couple notes, they'll let you kind of work on some problems like solving proportions or figuring out which fractions are bigger. So I'll just have a couple notes they'll put on the board, plus you'll be able to help, okay? Remember, we don't have classes tomorrow. Page 60, 63 is due today. So if you have not turned that in at some point today, make sure that gets turned in. Okay, because I know that we're not here tomorrow. Let's see, Thursday, I'm not here, so you'll have your sub, and parent-teacher conferences tonight and Thursday. So I'm not here very long. So tonight I think I'm here from like 4 to 5:30-ish. A little bit sooner than that. I know I have one parent-teacher conference that's already scheduled, so. But if your parents would come, I'm here almost all night on Thursday. So there you go.
You know, today, tomorrow's gonna be so relaxing. Not for me though. Okay. Show me the fun. Show up to the
I got work today.
Stay up until like 2:20.
So you did last night? You stay up and play Battlefield all night?
No, I stayed up until like 9. But tonight, I'll play.
How's the online? Is it working out?
It's really good.
Is it?